All right. So today we have one more pattern to do. Well, two more things. And we do have homework. And we're doing 3.9 today, and the homework is day 24, something like that. Which is the back of the page. Well, we can look one whole page down. And then, 3 more pages to go, but shh. Okay, so, that doesn't look like a tutorial. Okay, so from chapter 2, I asked you guys to just know this one, and then to prove trig functions. I showed you this one. You don't need to memorize it. You will eventually learn L'Hopital's rule, and you won't have to use it. Like, you won't have to memorize that. You can solve it using L'Hopital's. Same deal with this one, but I need this for a proof I want to do in a second. So, looking at it, where does the limit of the function go as x goes to 0? 1. Okay, cool. Okay, so, I will do this here. F of x plus h minus f of x over h. How do I pull apart exponent things? Sam?
You could do e to the x times e to the h minus e to the x.
And you will panic, like you all know how to do this. You will panic when you see this in chapter 9 because it's chapter 9 and you just be like psyched out. But you do have the technology, you really do. Okay, but from here, I'm gonna factor out that e to the x. That look familiar? What did I go to? 1. So by limit definition of derivative, looks like e is its own grandpa. So can you guys write that down? Derivative of e to the x is just e to the x. Crazy. It's the easy one. And we will do this also in chapter 9. Do the derivative of its Taylor expansion and get itself back again. Oh my God, it's so good. You do not share my excitement? There, thank you, Andy. I can tell you're in theater. You're pretending, but it was a good effort. Thank you. Okay, can I move on to stuff? Okay, so for other things I need to do today, I kind of need y'all to remember properties of logs. So Ben, log stuff plus log stuff. How do I smush them together?
If they have the same base, you can multiply them, right?
So.
Oh, wait, no, if you multiply, then you can add them. Wait, it's just. I got it backwards.
Okay.
Yeah, okay, yeah.
So addition across like logs is multiplication within. So Felipe, what is subtraction?
Addition.
Is division inside. What can I do with that them theirs? Yeah.
You can raise b to the power of c.
So it comes in as an exponent on the little argument in there. Okay, 4 is asking us to do change of base. Do you guys remember how to do that?
Yeah.
Monica, how do I do that? Base goes in the basement. That one goes underneath. And computer science people, I used to have to change to base 2, base 8, and base 16 all the time. Fine, fine, you want your base 16? Here you go. And when I write log like this, what's the assumed base? 10, okay. And ln is base E. Okay. Yeah, just checking. And you guys have already had to do this on a previous test. Some of you, in the way you solved the question, you got that, and it was not one of the multiple choice options. And some of you struggled with it. Bring then that in as an exponent. So negative natural log of a half is also known as natural log of 2. They didn't intend to be mean, but if you go about it a different way, you might get the other form. So logs, you might need to use your knowledge from algebra 2, I think is where we started these. Milo, you look thrilled with that idea. Or, yeah, the wave, here comes back. One person doing the wave, doesn't work very well. Okay, so you might need your properties of logs to change how it looks. Okay, derivative of E is E. There it is, that you now need to do chain rule. Can you try that one? You have, what do you get?
X times secant squared x.
And I don't know why, but I always put the chain rule thing in front. Secant squared x times e to the tangent x. So derivative of e to the whatever will always, it's like secant sucks. E to the whatever will have e to the whatever in it. Hang on, you're broken. I'll do that. All right, and then times derivative of stuff, yes.
Wait, so it doesn't matter if there's anything, as long as there's an e to the something that the e to the x thing holds?
E to the stuff is e to the stuff.
Okay.
Then times derivative of stuff. And I have it on good authority that stuff stays with you into college. My daughter's like, I hear them saying times derivative of stuff. Like she's with BCC students and they're like, yep, derivative of stuff. All right, this guy. Come on. Let's see. I don't know how to do, Jeremy, pick a number.
4.
4. All right, so we're gonna see if we can do the derivative of 4 to the x. All right, I don't know how to do that, so do E and ln undo each other? Are they inverses?
Yeah.
Yes, so I can square and square root, I can e and ln something, and it's fair game? Okay. So e to the ln of this and we just did the log rules, I can take that x down up front. Okay. Alana, natural log of 4, is that a function or is that a number?
It's a number.
Just a number. Okay. So, Lily, derivative of e to the stuff is e to the stuff times the derivative of stuff. So what's the derivative of this? E to the stuff, right?
Yeah. E to the x times 1.
Well, and then,
Times-
Alana, can you put that away? Okay. What's that derivative?
E to the 3x, 3e to the 3x.
Now, I realize you guys have bias against numbers, but it's just a number. So you multiply by 3 here. You gotta multiply by the schmutz. It's still just a number, like any other number. It has equal rights. Okay, and now I don't like this business over here. Natural log of 4, and I'm gonna turn this back into what it was. All right, so the derivative of a to the stuff is a to the stuff times derivative of stuff. And then there's this, like, it's not e, so you gotta pay to change the base. And this really is change of base. ln 4 over ln e, what is the natural log of e? 1. So it was just changing the base. So there's the pattern. Written with chain rule in it, for whatever reason. Milo, what's the question? And it is rare for them to put this on the test, but it happened last year. So sorry. It's chain rule-y stuff. So this guy, e to the stuff is e to the stuff, so 3 to the stuff is 3 to the stuff. Times derivative of stuff. And then it wasn't e, so I need to pay the conversion factor. So if you get stuck, just remember, e to the stuff is e to the stuff, so 3 to the stuff is close. If it's multiple choice, you can at least probably fight your way through and be like, kind of looks like this guy's pattern. Yeah.
Is the reason you need to introduce the ln so that we can get the e to the x equals e to the x rule to work?
I mean, like the reason that I had that change of base thing was right here, Jeremy
Right.
said that I was allowed to change that, and I was like, well, I'm gonna. And that's just a number times x. So when I did the derivative of that stuff, that came out. Okay. Needed the title, otherwise I don't remember what I was supposed to do here. Okay, this guy. I don't know how to do the derivative of natural log. What do I have to do to pull natural log off of something? E it, exponentiate, e it. So e to the y equals, what is e to the natural log of x?
X.
X. Evelyn, what was the derivative of e to the y? What did we just do? It is e to the y. And then chain rule, what's the derivative of y with respect to x? dy dx. Milo, what's the derivative of x?
1.
1. So then, dividing, I get 1 over e to the y. Just like that trig stuff, I don't want y in there. How can I get rid of it? I don't want e to the y.
Why is now an X? And then you sub it in.
Okay, yes,
Well, at the beginning, we started with y equals ln of x.
that's what he just said. There's something,
Oh, I didn't hear about that.
what is e to the y?
X.
X. Some of you said from the beginning, y is ln x, so e to the ln x, you would get there too. But I have it on the board, e to the y is x, let's just swap that out. So natural log of x is the easiest derivative ever. Well, I guess e to the x is the easiest. So Sophia, natural log of bleh, what's its derivative gonna be?
1 over all that stuff.
And then chain rule,
Times like the derivative of all that stuff.
which is just the stuff inside.
6x minus 4.
Looks terrible, but she's not so smart. Like, oh, blah. There it is.
Pull out an x from the bottom if you really want to.
What?
Pull out an x from the bottom if you really want to without not helping.
Doesn't reduce anything, so I'm not gonna, but yes, thank you for the thought. Try that one. It's easier than what she had to do.
Yeah.
Let's throw it up.
Andy, what'd you get? Oh, he's
Got
writing it on the board.
Oh.
Yeah. Sorry, it's a total maze to get up here.
dy over dx equals 6x over 3x squared, which equals 2 over x.
My job.
I concur. Good? Okay. Oh, Lord. And there's this one. Oh, no. Okay. I don't know this pattern at all, other than, I mean, I do. Just because it's got a sound to it. But, change a base, change this to natural log. And then G, how do I change it to natural log? I gotta do that change a base thing that we talked about.
Oh, log
Here.
of x over log of x.
Okay. She says, base goes in the basement. Natural log of x over natural log of a. All right, a is just a number. So Daniel, natural log of a, is that a number or, yeah? So it's just a coefficient. It's like the number 2. Okay, Well, if I asked you, what's the derivative of 3 natural log of x? Francesca, what would you say?
Sorry, can you?
What's the derivative of 3 natural log of x?
It's 1 over x, or, yeah, 1
And-
over x times 1.
Well, but the 3 stays there, right? It was there in first place.
Okay.
So
So 3 over x.
3 over x. Okay, so this one, I just did change a base, or she did. This 1 over natural log of a, you know, it's just like this 3 over here. It's just a number. So he's still there, and then the derivative of natural log of x, Francesca's like 1 over x. Yeah, that's it. And when it's in like chain rule written form, it looks like ulna, which is an arm bone. And people are like, ulna. Sounds like a Swedish name. The teacher before me had a big story about this Swedish person. It was a thing, I don't know. Any more than you already did. Okay. So we've got the 4 new patterns. We still have to do logarithmic differentiation tomorrow. Oh, so just to make sure that you have them written correctly, here they are. E to the stuff and natural log of stuff. And it's not exactly the clean thing like the trig inverses and the ones that begin with C, but e to the stuff is e to the stuff. A to the stuff is a to the stuff, and then you gotta pay the exchange rate. Natural log of whatever that base was. And this one, use your pre-cal or algebra 2, change the base, and then do the log derivative. Questions? So there is a test on all things chapter 3 on Thursday. I have to do logarithmic differentiation with you guys tomorrow, and some other tricks. But while I hand back your other tests, try these problems. Think before you derivatize.
You're supposed to like make that a -9.
Lots of comments about the corrections, like you're still doing things in some kind of crazy ways that are not helpful. And you should probably check so that you're just streamlining. Alex. And if you have not started these problems as divide and conquer, stop and rethink. looking at the test. But can you guys look up here for a second? So if the denominator is a simple little lump and the numerator is just ugly, pull things apart. The derivative of this is so much easier than quotient rule. Multiply by the power, lower the power. The power is -9. And then lowering the power from -9 down one more is -10. 6 times 20, 120 minus 6, 114. And this one, multiply by the power, lower the power. This guy, multiply by the power, lower the power. How do I do the second one? You have, what's the second one, Gumby?
15 over x.
Multiply by the power first and then lower. So the current power,
10.
multiply first, then lower, yeah. And this one, 7 times 5 halves. Lower the power.
Wouldn't it be minus, not plus?
Yes. Okay. Questions about the test that you guys got back? First period asked about this one. When it asked for the tangent line through 0. Well, the derivative, multiply by the power, lower the power, and then chain rule. That derivative when x is 0, at the top of the problem, which was granted 2 parts away, it said f of 0 equals 3. And it said f prime was something horrendous. Cosine pi x
Plus 2 squared plus 6.
Okay, f prime of 0, cosine of 0. You guys need to remember unit circle. Cosine of 0 is not 0, it's 1. Okay, 2 times 0 squared, well, that's conveniently 0. So the slope was 42. Now, before you ask me at the end of class, come up privately and say, why was this 9? I'm trying to tell you here. This guy, y, when x is 0, is f of 0 squared. What was f of 0? 3. So this guy was a 9. Y minus the y value equals x minus the x value. Do you need to write x minus 0? No. The parametric question, when I asked, give me the coordinates, a lot of you use t as x. X is not time, x is how far sideways you are. So, and vertical tangents are allowed to happen. You can't do the derivatives there, but when does a vertical tangent happen? When dx dt is 0. And goodness, y'all need to slow down or something. You guys factored this wrong, like half of you, like really a lot of you factored wrong. And it's just careless, but that means slow down. Because they made this really hard to give you partial credit, because if you trivialized the question or changed it too much, it was like I didn't know how to award points. So vertical tangents happen when the denominator of the slope is 0. And I believe this was the equation. So vertical tangents happened at time 0 and time 1, which is not the coordinates. And some of you plugged them in and you left answers in this weird way of, like, I don't know what the heck that is. Since when do we write coordinates like that? So the coordinates were 0, 0, and -1, -11 in the little hugs. This X with that guy's Y. But a number of you put in the T value there rather than calculating X. So I don't know if people ran out of time because, I don't know. Other questions from the test? That was just weird or funky, yeah.
I'm so confused about this one. So what was the right answer?
This is what are the coordinates of the vertical tangents? Right there.
Okay.
So this was part C, was where's the denominator 0? And some of you got an earlier question that needed dx dt wrong, but you copied it over, like you started from scratch again and did the right thing here. Cool? But if you got that and set it to 0, the 2 times, Jeremy, that it's 0, or that the denominator was 0, so where the vertical happened, was at time 0 and time 1. And x was like 2t squared? I don't know. Something like that.
2t cubed.
2t cubed and,
Squared.
okay. And y was,
T cubed minus 12.
so putting in 0, I get 0, 0. Putting in t is 1, I get x is -1 and y is -11. Other questions? And again, I told you guys already about the derivative of the trig one. Before doing the derivative, simplifying would have been so much easier. What's the derivative of sine? Cosine. A lot of you did very, very lovely trig proofs and worked very hard to get that identity to get down to this, and you spent way more time than you needed. Yeah?
If you didn't do it like that, what was the proof you needed to do?
Well, people did product rule. First times the derivative of the second, plus second times the derivative of the first. So they got cosine over cosine squared, plus sine squared over cosine. One of these reduces, so, whoops. Derivative of cosine was negative sine, so that's a negative. So 1 minus sine squared over cosine. Swapping that out, cosine squared over cosine. So, and some people got stuck and reversed and started over again. They did the proof 3 or so times. And the work that I did on my test was this. It was just faster. Less chances of mistake. And some people said, now you have a typo in your answers, I'm gonna take this one and change the sign. Sorry, no. Granted, I do make enough typos that is potentially, potentially real, but it was not. Other questions? Yep.
Will the quiz or the test this week be calculator too, or just no calculator?
I'm averse to calculators. And I'm averse to having to do the lockdown on, because if you're allowed to use Desmos, and I hate it. So I'm at the moment I'm going with non-calculator.
Okay, in just one day.
One day. That's why we had this one earlier, so that you didn't have two in a row. Yeah.
Is this our last unit test before the quarter ends?
Quarter ends on Halloween. There might be other things like an optimization project that goes into the grade book that is a significant grade thing,
Okay.
but we won't have time for a quiz or a test. Some, 30-ish, 40-ish, they're all about,
So not like a lot more than.
shouldn't be, yeah.
Are we able to we have retake opportunities at the end of the quarter?
So at the end of the quarter, you can retake any one quiz, which,
Is the prereq included on that, or?
sure. Prereq was what, 7 points? 12 points? Oh my goodness, 12.
How old is it?
So yeah, there are retakes, one quiz and one exit card. Did we only have one exit card? I don't know. Yeah.
So I think the quarter is that like before the end of the quarter? Like-
So it'll probably be the last week of the quarter where you can, I'll ask you on the weekend before, pick what you want to retake, or that you do want to retake the one quiz we have, and then it'll be in that week at lunch.